This video will be an introduction to Pandas DataFrames. So Pandas, like NumPy, is a Python library. We use it for data manipulation and analysis. It's built on top of NumPy, and it's essential for data preprocessing and machine learning in Python. Most machine learning algorithms and libraries require that data is in a data frame format. Pandas presents data in a tabular format, and we call that a data frame. And as I said, there's a lot of built-in tools for a variety of different purposes, but notable ones are for data cleaning, data engineering, and data analysis. Similar to NumPy, you do need to import Pandas because it's a library. It's not built into Python, and you import it by writing import pandas as PD. This would go at the top of any Jupyter notebook or Python script that you create. Now, data can be formatted in a one-dimensional series or labeled array, or a two-dimensional data frame, which is similar to a table in Pandas. And we're usually working with data frames and not so much series. Now, you can create a Pandas data frame in several ways. Within Python, you can create a data frame from a dictionary. So an example here is our data is formatted as a dictionary. Each of the titles of our columns, or what will become columns, are in the key side of the dictionary element, and on the value side, we have a list of each of the values which will form the rows in the data frame. All that you need to do is write pd.dataframe and then in the brackets data, which is the name of our dictionary, and that will create a data frame for you. And you can see all the way on the right, if you want to print that data frame, all you have to do is write the name and run the cell, and that's how the data would look in a data frame. More common than from a dictionary, you might create a data frame from a file. So usually raw data comes in a CSV or Excel format, and you need to import it into Python and Pandas. And you can do that by writing pd.read_CSV or pd.read_Excel, depending on the file format. And then in brackets and quotation marks, the full file path on your computer. Now, there are many functions and methods that you can use in Pandas, similar to NumPy. These are just a few of them. I encourage you to have a look at other ones, and I'm sure that you will come across many more of them in the next 2.5 weeks, and certainly in any machine learning projects that you do in the future. We'll start with the basics. So if you want to just see the first few rows of your data frame, you can use the command head. So you just write dataframe.head and then in parentheses, however many of the first rows you want to see just to get an overview of the data frame. You can also write dataframe.tail and similarly specify the number of rows you want to see from the bottom up. If you want to select a specific column, you just write the name of your data frame and then in square brackets, the title of the column that you want to select. This is really similar to when you index in a dictionary. So instead of indexing by index, you do it by key. And in this case, you do it by title. So this is how you would select a very specific column. You can also select multiple columns, and you do that by basically within those square brackets. When you would select one column, you add a list of all the columns that you want to include. So you could either previously title and specify a list of columns, or you can just put the list right in there in those square brackets, and it'll look like that. You can also filter the rows of your data frame based on a certain value in a certain column. So you might want to only see the data for people who have a blood glucose level that's greater than 4.5, as an example. You might also only want to see the data from patients with a patient ID of 2, and that would look a little bit different. Maybe think about how that would look. There's a lot that you can do in terms of filtering your rows. You can also gather the descriptive analysis of your data frame really simply by just writing dataframe.describe and parentheses, and this will give you the count, mean, standard deviation, minimum, and maximum values, along with all of the other values at each quartile. Another really important part of Pandas when you're preparing data for machine learning is dealing with missing values. And the first step in dealing with missing values is identifying where they are. And in order to do that, you can just use this very simple command, dataframe.isna parentheses .sum parentheses, and this will tell you in each row how many missing values there are, which gives you an opportunity to figure out where you need to look to understand where data is missing and possibly why. Now, if you want to just drop all of the rows in your data frame that have missing values, you just do that by writing dataframe.dropna and parentheses. And you can see here we're reassigning this to the title data frame, and this means that we're updating our data frame so that it now only contains the rows that don't have any missing values in them. If we hadn't reassigned this value, if we just typed df.dropna, we would see a preview of the data frame where all of the missing values had been dropped, but that wouldn't actually have registered and updated the data frame. It's just kind of a view for us of that. You can also print the data types for each column. Again, a lot of the time, certain machine learning libraries only work with specific types of data or with compatible types of data. So it's good to know what type of data you have. And you do that very simply by just writing the name of your data frame, .dtypes. Now, these are a few ways that you might use pandas in a specific machine learning context. We have an example data frame across the top, and there's a few things that we want to do with it to modify it and prepare it for machine learning. First, you might want to create a new column based on existing columns. So you have participants' weight and height, but you might want to use their BMI instead. And the way you do that is by doing a little bit of math. So first you create a new column in your data frame, and you do that in a similar way that you would select an existing column. You just write the name of your data frame and then in square brackets, the name of the column that you want to create. You add an equal sign, and then on the right of the equal sign, you select the columns that you want to do the operations on, as we have here. So you select the weight column and you select the height column. You divide weight by height to the power of 2, and then this performs an element-wise operation, which means that for each row, you do this specific function and you get your BMI column. So that's an example there. You also might need to integer encode a categorical column. So your machine learning algorithm is not going to know the difference between healthy and diabetes. It just knows the difference between numbers, and it doesn't work well with string values. So you'd use a dictionary, which we discussed in the list and dictionary video. If you want to assign these values, replace them in an existing column, instead of defining a new column, you just select the column you want to update, equals, select that column again, dot map, and then in parentheses, you write the dictionary that you want to use to map these values or change these values. You can define the dictionary above and then just put the name of the dictionary in those parentheses, or you can put the full dictionary in as we have here. And this will update all the values that are healthy to a value of 0, pre-diabetes to a value of 1, and diabetes to a value of 2. And you can see that in the example printed out new data frame below. Finally, you might want to drop missing values because, as we discussed, machine learning algorithms don't do well with missing values, which are presented as nans here. And if you don't want to assign the dropna df to a new df, you can also do it this way. You can write df.dropna, and then in the parentheses, instead of leaving them empty, you just write in place equals true, and then it does the operation in place for you, and it's set, and the data frame has been updated. Let's challenge yourself. So you are given patient data in a dictionary format. I've written it out here. You can go in and copy this over to your exercise notebook, and then go ahead and try to answer each of the questions we have. All right, let's run through the answers here. So for question A, you were meant to make a data frame out of the dictionary, and you do that by using the command pd.dataframe and then in brackets the name of your dictionary. It should look like that. Then you want to go ahead and drop any missing values, and you've chosen to do that by reassigning the data frame to its original name, df equals df.dropna. C, you want to create a new column called risk, and you're doing that using the formula that I gave you in the previous slide. And then D, you're going to integer encode the smoker column so that yes is 1 and no is 0. How did you do? Let me know.